Hi viewers. Yeah, we have another question on motion in one dimension. A very simple question at that. So now let's see how we can solve this question. Right. We have a person walks first at a constant speed of 5.00 meters per second along a straight line from a point A to a point B, that's to point B, and then back along the line from B to A at a constant speed of 3.00 meters per second. Okay, what are our average speed over the entire trip? Okay, and our average velocity over the entire trip. Now, we have two different cases here. Of course, we know that speed and velocity, they have the same unit of measurement. Okay, that is, now, because we know that the unit of speed is, when it comes to, in terms of SI unit, it is measured in meters per second. Then velocity is also measured in what? Meters per second. But there are two different quantities. Okay. Now, we know that speed, okay, tells us how fast a body has moved or a body is moving without taking into consideration the direction along which the body has moved. Okay. But when it comes to velocity, velocity tells us how fast a body is moving and the direction along which the body is moving, or as so like that. So and that is why when it comes to velocity, velocity measures the change in position, okay, with respect to time, okay, or we can say change in displacement with respect to time. But when it is speed measures, the distance traveled, okay, by a body, okay, in an unspecified direction, okay, with respect to time. So that's in the case of speed. So that's why I say we have two different cases here. What are our average speed over the entire trip? Okay, that is what our average speed, during the interval of time, you know, the person walks. Okay, same with average velocity. So we have two. The first one and this now the two questions in this case, there are two different questions. So let's not mix it, but let's see how to to work it out. Okay, now, so the first question is for us to calculate, you know, the average speed over the entire trip. Okay, average speed over the entire trip. So first thing first, now we need to understand that when we talk about average speed, okay, average speed, okay, in terms of measurement, average speed measures total distance traveled, okay, total distance traveled or transverse, okay, total distance traveled, okay, over total time taken. That's total time taken. Now, what is the total distance traveled? Now, let's say we have the girl walks from point A, okay. Now, a person walks first at a constant speed, at a constant speed, okay, along straight line from point A to B. Okay, she walks from A to B, okay, at a constant speed. That's at the same velocity, okay, at a constant speed, okay, and the constant speed from A to B will be equals to 5.0 meters per second along a straight line. Remember, motion in one dimension is the motion describing, that's the motion, the motion describing a body moving along a straight line. Okay, so now we have the person walks from A to B at a constant speed 5.0 meters per second, and then back along the line from B to A at a constant speed of 3.0 meters per second. Now, the time will change, okay? The time will change, but the distance will remain the same, all right? So that is the idea in this case. So the person walks from A to B. The person walks from A to B at a constant speed, 5.0 meters per second, and then back along the line from B to A. So let's say from B to A, that is from B to A. That means the walker, return to the starting point, which is point A, okay, at a speed of, that will be BA, okay, that will be BA, and that will be equals to 3 meters per second, 3.0 meters per second. Okay, so it is important for me to indicate the arrowhead in the line diagram, okay, for us to tell the direction, okay, that is from A to B, okay, is 5 meters per second. Then from B to A is what? Is 3 meters per second. Now, distance, note, distance from A to B, okay, equals distance, okay, from B to A. So this is very important, okay, distance from A to B, okay, equals distance from B to A, because the length of path traveled by a body, all right, is what we call distance, or the extent of separation between two fixed points is what we call distance. So if we have the person to walk from A to B, if the same person, and he also walks from B to what? To A, so it means the person is going to cover the same distance. So which means that distance from A to B, okay, will be equals to the distance from B to A, and that will be equals to what? D. Okay, so in this case, so like I said, we have average speed, okay, we have average speed to be equals to total distance. So which means whether we write DAB plus DBA, okay, over what? The total time. Now this is very important. Now what is TAB? Because we are given in the question that this, now a person walks first at a constant speed of 5.0 meters per second along a straight line from a point A to point B. So the time, okay, the time for which she walks from A to B will be TAB, okay, and time, okay, time will be speed, okay, time will be speed. Now distance over what? Distance over speed. So we have VAB, okay, VAB, that is DAB over what? VAB. Then for now, when she then walks, from B to A, so the time will be TBA, which will be DBA over what? Over VBA. And let's not forget that DAB is equals to DBA, and that equals to what? D. So let's go back to what we have here. So we're looking for the average speed. So the average speed will now be D plus D, okay, over what? Over the total time, which will be D over, now what is VAB? VAB is 5 meters. So we write 5 plus, then what is VBA? That's 3. So this is over 3. Okay, so now let's simplify this. So we have V average, okay, that will be 2D all over. So in this case, this will be 3D plus 5D over what? Over 15. Okay, so that V average will be equals to 2D over 8D over what? 15. Then we can what? We have to simplify further. Okay, so in this case, the average speed would then be 2D multiplied by 15 over what? Over 8D. So that this will be, so we are going to what? This will cancel out, so that the average speed, okay, will be equals to 2 multiplied by 15 over 8. And this can be evaluated to be what? 2 times 15, that's 30. That's 30 over 8. So that the average speed will be equals to, now let's reduce this. We have 15 over 4. And what is 15 over 4? That will be 3 points. 3 times 4 is 12. We have a remainder of what? 3. So in 30, that will be 28. That will be 7. Okay, because 7 times 4 is what? 28. Then in 20, that will be 5. So this will be 3.5 meters per second. So therefore, the average speed over the entire trip will be equals to 3.75 meters per second. This is the answer for A. All right, B. Now, this one okay, now let me explain this. We want to, what are our average velocity over the entire trip? You know, you recall I said, because she walks or she returns to the starting point. So which means the total displacement, all right, the total displacement will be D minus D, okay? You know, since, all right, now we want to calculate average velocity over the entire trip. So we can say, let V, now I have to put a directed line segment because velocity is a vector quantity, while speed is a what? Is a scalar quantity. So we have velocity to be equals to change in position over what? Change in time. So the change in position in this case, okay, will be D minus D, because the distance transverse, remember, she walks from A to B and then from B to A and at the same what? Distance. So that means distance from A to B and distance from B to A, they are what? They are equal. All right, and that's what we have here. So this will be what? 0. Okay, so which means now, since the person, okay, returns to the starting point, okay, then we have the what? The total displacement, which is what we have as change in position, will be equals to 0. So therefore, the velocity, okay, V will be equals to 0. So it means that the velocity, okay, the velocity over the entire trip, okay, which is this guy, is equals to 0. Okay, so which means now we have average speed. This is average speed is 3.75 meters per second, but the average velocity over the entire trip, okay, is equals to 0. That is because the total displacement, okay, will be equals to 0. Remember I said, now the distance in this case, okay, the distance traveled from, you know, from point A, all right, to point B is equals to that from B to what? To A. You know, she walks from B to A. After she walks from A to B, and the distance will be what? Will be constant, but the time and the what? And the speed, you know, they vary. Okay, so, and like I said, the average speed over the entire trip is 3.75 meters per second. So the average velocity okay, the average velocity over the entire trip, okay, is equals to 0. That is, it will be, this is the average velocity, and it is equals to what? It is equals to 0. The noblest pleasure is the joy of understanding. Bye bye.